Okay, so number 3 reads f of x equals x cubed minus 3x squared plus 3x. So first, to find the zeros, you set this first function equal to 0. So 0 equals x cubed minus 3x squared plus 3x. Factor out an x. And then you can solve from here. So you get x equals 0. And then when you do quadratic formula on this little bit right there, they are complex numbers, so they do not exist. So your only answer is you will have a 0 at x equals 0. Now, the first derivative test would be taking the derivative of this function up there. So it would be 3x squared minus 6x plus 3. You can factor out a 3 to make solving a little easier. And then you can set that equal to 0. And you get x equals 1 because x squared minus 2x plus 1 factors to x minus 1, x minus 1. So when you do the max-min test, you get on the left side, so I plugged in -1 and still got a positive number. And then I plugged in 10 on this side and still got a positive number. So because it's positive on both sides, that means there's no extrema for this function. Now, okay, so the first derivative graphed would be f prime of x equals 3x squared minus 6x plus 3. So since we already said our critical number was x equals 1, we know it's 1, and we said that it's increasing on both sides, so that would be increasing just like this. Second derivative test is 6x minus 6, and then you just set this function equal to 0, and you get x equals 1 again. So then, when you do the sign test on it, you get on the left side, it's minus, and then on the right, it's positive. So this means that it is concave down from negative infinity all the way up to 1. And it's concave up for all values after 1. All the way up to infinity. Okay, so our second derivative would be f double prime of x equals 6x minus 6. So our critical number again was x equals 1, and we said 6x minus 6 would just be graphed, would look something along the lines of this. There's no horizontal asymptotes on this problem because there's no denominator at all over here. And there's also no vertical asymptotes because there's no denominator once again. And it's a polynomial, so that means no denominator as well. So your graph in the end will look something along these lines. So you have that inflection point at 1. You have crosses it at 0. Something along those lines. F of x equals x plus sine of x is the first one in the trig functions. So to find the 0 here, you just set it equal to 0. And you get 0 equals x plus sine x. So then you go negative x equals sine of x. And the only time that this is true is when x equals 0, because sine of 0 is 0, and 0 is obviously equal to itself. So we have here a 0 at 0. So first derivative test is f prime of x equals 1 plus cosine of x, because that's the derivative of this function. So then you set that equal to 0, and you get 1 plus cosine x, equals 0. So then you get negative 1 equals cosine of x. And here, when x equals pi, is when that is equal to negative 1. But on the sign test, when you look at it on the left and the right, it is both positive. So, there's no extrema. And that is on an open interval, so no closed intervals. Okay, so the first derivative up here, 1, I'll just write it down here, 1 plus cosine of x, the graph of that would look something along the lines of this. So, it basically is just a regular cosine graph with a plus 1, so it's just shifted just a tad. So as you have it just goes like a regular cosine graph. Starts all the way up here at 1, comes down to pi, undulates back up. Well, see, the only problem is this is 2 up here, and this is 0 still, remember? Instead, it does not come down to negative 1, like it should as a regular graph, that's where that plus 1 comes in. Now, on the the second derivative test, you take the derivative of this function, and you get negative sine of x. So setting that equal to 0, negative sine of x is equal to 0 only when x equals 0. So on the sign test, you get, on the left, it would be positive, on the right, it's negative. And this is because when you plug in a number smaller than 0, it will be increasing, but when you plug in a number larger than 0, it's decreasing. So your concave ups and downs vary on every pi. So it's concave up from negative pi to 0, and on pi to 2 pi. And it's concave down on 0 to pi, and negative 2 pi and negative pi. Okay, so our second derivative test, graphed, would be f double prime of x equals negative sine of x. So the negative sine of x would look something like this because it's just a regular sine graph with a negative 1 thrown out in front. So that basically just flips it, or literally flips it. So you just have it coming through 0, comes through pi, undulates back down to negative 2 pi, or back down to 2 pi, and then it comes back over here, negative pi through negative 2 pi. And there's no vertical or horizontal asymptotes. And this is because, like again, in the one that I just did, there is no denominator. So it is not even possible to have anything because there's nothing down there. Now a graph of this function would look something along the lines of this. So that would be 0 right there. Let's call that pi, and we'll call that 2 pi. We can say this as anything, so 1 and 1, that's negative pi, negative 2 pi. So something like this, with that inflection point changing at the pi and at 0. So it's going up, it's going down, it's going up, it's going up. Okay, so that's it.